Good morning, strength students, and welcome to Chapter 9 and our new reality on teaching engineering technology. It'll be interesting, it'll be fun. Communicate with me, and I think we'll do fine. Not going to give you a lot of headshots, but I did want to say hi and let you know that I'm here for you. If you need anything, just reach out. Most of your shots are going to come to you like this. And we'll work out of the book some, and we will work on pencil and paper. So Chapter 9 is all about stresses and the introduction of stress. So stress is the material's ability to resist force. So we have to start with the concept of tensile and compressive stress. When a system gets loaded, any kind of a system, it's either going to produce a tensile force pulling away on an object, trying to pull it apart, or a compressive stress. So that's the first thing we set up. The equation for it, P over A. So P over A is the primary equation for stress all the way through this class. It'll come to you in a lot of different forms. P being the external load and A being some kind of cross-sectional area. So for compressive and tensile stresses, that area is the same. It's the cross-sectional area. So if you have a rectangular bar, right, that cross-section, if we chop it, is a square, right? So depending on the object you have, that's the area you're going to use. Whether it is being pulled apart, that's tensile, or whether it's being crushed, that's compressive. It's pretty easy to demonstrate. If I have an object, right, and I push on it like this, I'm compressing it. And it actually changes length. So this will actually get shorter when I push on it. Maybe I'm pushing 10 pounds. Same with pulling on it. But those are two different stresses. And sometimes the stress that we consider, whether it's tensile or whether it's compressive, and I do believe they use, they use the Greek symbol sigma. So we will use sigma also. Some books you'll see the S, some books you'll see a sigma. That'll be my sigma. And I'll put a little T down for tension. And I'll put a little C down for compression. Right? And those are different stresses. The equation, P over A. So this is, P is going to be your load, and A is going to be your area. So this is the average stress over this cross-section. So when we pull on something, the stress right here at this connection point could be very high. But if I go a ways away from this connection point out in here somewhere, then that's where we're going to get this average stress. At some point in the chapter, we'll work on these stress concentrations, these higher stress levels. But for now, we're just going to work with these average stresses. Where we're going with this is materials can take different stresses. Wood, for example, that'll take a certain amount of stress. Steel will take a different amount of stress. A bungee cord will take, again, a different amount of stress. So the reason we calculate stresses is to compare them to some kind of a limit. So the limit stress for steel on average is 36,000 psi. When you run this equation and you put pounds in here and an area in inches squared, you're going to get PSI, pounds per square inch, and that's the unit of stress. So our first task is to calculate these things, right? So in the book, there's some nice example problems for you to work through and understand where they're using this P over A to calculate a stress on an object. So a lot of times they're going to give you this material. Whoops, sorry. Right? They're going to give you the tensile stress developed on a steel bar. So they're giving you that because at some point we're going to want to like compare the steel limit to whatever we're calculating. So we have to understand right away that when we calculate a stress, that's our calculated stress. It's not telling us whether it's good or bad, it's just the stress on the system. We would typically compare that to some kind of a limit. We're not going to go there yet. We're just going to get used to calculating these stresses. So they can be, like I said, tensile or compressive. Here's an example of a compressive problem where we have a chunk of wood and we're going to load it down with 100 kilonewtons. Again, just running P over A. All right? That is the basics of tensile and compressive stress. The next section will be shear stresses. So we're not going to go there yet. I'm going to keep these videos very short. So just P over A on this first one. All right, you have a homework assignment that you have to do, and get that done, and then I will post up the solutions to the homework assignment. I'm not exactly sure how I'm going to give you feedback on your homework yet. I believe I'm going to use an iPad and be able to write on your homework and then send it back to you. But for now, I'll post the solutions. I'll work these problems, and you'll see the examples. All right, let's give this first homework set a try, and then you can move on to the next one. Have a good day.